Okay, so today we're going to learn about distance equals rate times time problems, or what I like to call dirt problems. And the reason these things come up is if you've ever thought about like a car ride or how long it takes for things in a car. If you're going 60 miles per hour and you drive for 5 hours, if you just take the 60 times the 5, you can go, oh, if I drove for 5 for 5 hours and I'm going 68 miles per hour, I'll have gone a total of 300 miles. So there's my distance. There's my time. And there's my rate. So a lot of times, like word problems come up and they're of this nature. Now there's two types of distance equals rate times time problems. And it's if you think about cars, it's the two things like different cars could do. So let's say I have a car here, and I'll call this car 1. Let's say I have a car here, I'll call this car 2. There's two things that could happen. Car 2 could go this way, and car 1 could go this way. And I want to find the total distance if I added both of them up, how far they would have gone. The other thing that could happen is, let's say this time car 1 is behind car 2. And car 1 is trying to catch car 2. So they keep going, and I'm going to try to find the point where car 1 meets up with car 2. So these are the two types of problems we're going to see. So let's see some of these word problems and see what we can do with them. So here's the first one. It says that Callie left school and traveled towards her friend's house at an average speed of 40 miles or kilometers per hour. Matt left 1 hour later and traveled in the opposite direction with an average speed of 50 kilometers per hour. Find the number of hours Matt needs to travel before they are 400 kilometers apart. So when I'm reading that, that's a lot of information. I normally set up all my problems into 2 spots. So this is my car 1 or Callie, and this is my car 2 or Matt. And a lot of times, since rate and times equals distance, like up here, I just care about the rates and times for Matt and Callie. So let me just put that in. We're going to try to find the RT for this person and the RT for this person. And we'll figure out how the distance relates to all this. So when I read through, it looks like Callie is going 40, so I'm going to put that in. And it looks like Matt is going 50, so I'll put that in. Now I have to find the time. So it doesn't tell me how long Callie has gone. So I'm just going to say she's gone X hours. And it does tell me something about how long Matt's gone. It says Matt left 1 hour later, which means Matt has gone 1 less hour than Callie. So if I'm thinking about, he's gone 1 hour less. And if I think about how to write that, I would say, well, I'll take my hours, or X, and I'll minus 1. And now the last step is I'm going to figure out what type of problem it is. I'm going to try to figure out, is it cars coming together? Or is it cars going apart? And when I read, they're going in opposite directions. So this one's not correct. So it's cars going apart. I made somebody that looks like they're wearing glasses, but it's cars going apart. So we are going to take these two things, this side, and add them together. So I have 40x plus 50 times x minus 1. And that's going to equal a total of, well, let me look back up here, 400 kilometers. So we can see that that's 400 kilometers. And then let's start doing this. So this can distribute. 40x plus 50x minus 50 is equal to 400. I would have 90x minus 50 equals 400. I'll add the 50. I'll have 90x equals 450. Divide by 90, divide by 90, and x equals 5. So, I know that Callie has been driving for 5 hours, and Matt has been driving for 4 hours, because x was 5. Let's try a